Hi and welcome back to MDriven. I found this rather amusing and to the point video that I think describes code and the endeavors or the challenges with building information systems as a whole in a quite funny way. So let's go.
If I have to sum up my coding skills after 15 years of software development, I would probably go with something like average on a good day. This might sound harsh, but the fact of the matter is that a lot of devs feel the same regardless of the years of experience. In the world of software, feeling like an imposter is normal. So, weirdly enough, if you are pleased with the results of your current work, you are most likely wrong.
That's harsh, but mostly true. Let's see what it says.
Let me explain. Writing good software is actually really hard, but before going into the details, let's acknowledge the harsh reality of building software products, the only absolute truth we all end up accepting sooner or later. When it comes to software, beauty is in the eye of the beholder. In other words, nobody besides your team really cares about your clean code, your domain-driven design, or the layers of abstraction you preemptively add in your codebase. I am not saying this is right or fair, I am just stating a fact. Outside the dev team, people are way more pragmatic. Product cares about the customer.
True.
Sales cares about releasing new features.
True.
Management wants you working faster, better, and preferably cheaper.
True.
And QA simply wants you dead. Nobody knows what HR really cares about, but it's probably safe to assume it's not your code.
So I wouldn't know about the last two there, but the other things are really good to keep in mind. That we live in a reality where the software is gonna do some work, and that work doesn't really care on how it looks on the inside. But it's still really important to keep things ordered on the inside, as he's gonna describe further on.
With this in mind, knowing you are fighting an already lost battle, let's see why good software still matters and how to enforce it in a world filled with deadlines, conflicting priorities, remote work, and affordable streaming services. There is a big distinction between working software and good software. On the surface, it seems like good software makes developers happy, while working software makes everybody else happy. Here's the kicker though. Bad software that works will eventually stop working.
So bad software is brittle software, so stuff that breaks easily. That's bad software. If it's very robust, that's what I would categorize as good software. And what defines robustness? Well, that's harder. But basically, it's a hindsight thing. If it doesn't crash or behave as a zebra all the time, it's cool and calm, that's good.
There is a mismatch in priorities. As long as the software works, nobody outside the dev team will prioritize fixing it.
And this is also very true. If it works, no one will pay you to take a second look at it. And the normal thing as software developers do is, I'm gonna do this quick and then I'm gonna come back to it when there's more time. But there will never be more time. And software developers, especially junior software developers, don't know this fact. They think they will be given time in the near future or the future. But of course, they won't be given arbitrary time that they can do whatever they want with. They will only be given time to add new things.
It's human nature to focus on immediate gains, take the profits, and then kick the can down the road. However, in the long run, software must be well written so that it can evolve seamlessly and meet the ongoing needs of your organization.
So this is the key. Meet the ongoing needs of your organization. This is what MDriven focus on. The ability to change, the ability to always know what you have. Don't end up in enormous amount of code to try to understand what you have. Always be clear and declarative. Have the models easily available. Be sure and trust that the models describe the system 100% correctly. And if that's the case, changing things is very easy. If that is not the case, then you first have to spend time to understand what you have before you can dare change anything.
So, the bad news is that even though nobody else cares about it, writing good software is still your main responsibility.
So it's your responsibility to have this order so that you always know where the next change is going to go and what the next change going to affect and what's potentially this next change might make your software brittle, thus making your software bad. From have been good, one little change might tip it over to make it brittle. And this is really, really hard to know. And that's why you never should trust only memory. You must dive into the whole code base, and that's almost impossible. So you shouldn't have the code. You should have clear declarative models that are easy to understand and easy to see the side effects on what you do. When you do a change, what does it affect?
On the upside, writing good software is really easy, at least on paper. On one hand, your code has to be clean, concise, and well thought out so that you and your team can easily maintain and extend it in the future. On the other hand, it needs to be secure and efficient so that your product doesn't require an entire power.
This is perfect description, that is clean, nothing, you haven't put in a lot of stuff that isn't needed. It's easy to read, concise, that there's no second guessing, does this mean this or that. It should be precise and easy to follow. Should be planned. Of course, that's impossible if you don't have a plan from the start, and you never do. Of course, there's a plan, but the plan will have changed so many times, so nothing will actually be planned, but it still needs to be clean and concise. Maintainable. Very important that you are ready to enter the next changes to your system without making it brittle, without making it unstable, thus without making it bad software. Secure, of course, and that's really hard to know if everyone has coded along with different backgrounds and different knowledge about the landscape, if it really is secure. That's much better with a strategy like MDriven does, to project the system down from declarative models, because then you know that as long as MDriven is secure, what you do is fairly easy to ensure that you set the access groups on things so that people from that organization can't see things from that organization if they shouldn't be allowed. And of course, performant. It's the saying is, first make it work, then make it fast. And with MDriven, I'm not saying that you don't have to think about performance. Of course you do. You will always run into issues if you have when the number of objects in your system grow, and you will have to redesign due to get back the performance that you want and need. But it's always quite understandable what you have to do and where you have to do it. And since redesign is very, very much easier with MDriven than with code, this will not be the showstopper that it usually is.
Clean, well-thought code is much harder to assess though. After all, there is a reason you have 1000-page books on the simple concept of writing code.
Yes, so it's hard to write good code, and it's mainly one of the complicating factors is that code is used for so much. It's used for the infrastructure on how to move data around in your system. It's used to describe the data structures of the information in your system. It's used as UI display mechanisms in your system. And all of these things are totally different needs. With MDriven, you get a very clear separation of concerns. You have the information that actually builds up the gist of your system. And that's the most important thing, where the knowledge of the business problems go. And then you have a MDriven platform that supports you in infrastructure to get data into a database, up from a database securely through the different business layers up on the screen. So the problem that you need to solve for each requirement shrinks considerably using a strategy as MDriven. So you should definitely test to use MDriven in your early stages when there's a lot of flux in your requirements and everything changes from day to day. MDriven, that will be the key to success, to get clarity on what people said before, what they say now. Are there contradictions? Why are there contradictions? What are the true facts in this case? Where do we want to go? When things sort of level off and there's no changes anymore, this will never happen, but if it happens, if there are no changes anymore, definitely implement it with code. Because if you have it with code, you will gain a few percentage in efficiency, possibly, if you do everything correct, but you will lose 10,000% in speed of adding a change. But since you now don't expect any changes, that's fine. If you can reach an environment where you don't expect any changes, you can go with code. Otherwise, go with MDriven or a declarative strategy.
Despite being a complex, difficult topic, there are a few basic principles you can follow to ensure that the code you are writing is on the right path. There is a fine line between writing good software and writing overcomplicated, useless code. Experienced developers will tell you that you should always assume unexpected changes when writing code.
So I said that if you don't expect any changes to your system, then you can go with code. But of course, that will never happen. There will always be changes. And then going with code is an unnecessary complexity that will only bring you down.
Well, this is kind of dumb. If I'm expecting unexpected changes, those changes are actually expected, right? Of course, this is an oversimplification. The idea is that products are in constant change and your code has to easily adapt to new requirements.
Very true. Everything is under constant change. If it isn't, it will be... it's probably not needed anymore.
Abstraction is the main tool you'll use to make your code more flexible, but this can...
So abstraction. All coders use abstractions in different amount. What MDriven does is it takes abstraction up to the business layer so that you can use the language of the business and focus on classification and associations between things to get things done. This is a very good level of abstraction for getting things done and understood.
Easily become a slippery slope. Planning too much for what might come will lead to premature optimizations, which, as we all know, are the root of all evil. David Wheeler sums this up pretty well. All problems in computer science can be solved by another level of indirection, except for the problem of too many layers of indirection. The problem of over-abstraction can be easily solved with something devs rarely excel at, talking with other people.
Yeah, over-abstraction. Now we are on what level we should abstract. Of course, we're going to use the MDriven tools to get us models, but what should a model describe? And the only way to understand what the model should describe is to talk with the people from your domain, from your business, the ones that are going to use the system. Talk to other people. This is the key. It doesn't matter if you're a good coder if you can't understand what the business problem is.
Software development should not happen in a vacuum. You should talk with domain experts to deeply understand the business logic and ask questions as often as possible, preferably before you make any software design decisions. With a good understanding of the requirements, the next thing you should focus on is the form of your code. Uncle Bob's Clean Code has some great tips and tricks to make your code.
So code. And it's, of course, the totally wrong tool to actually get anything seriously complex off the ground. It's not made for change. in that way. As soon as you have written code, you have forgotten just a few weeks later the names of the variables, etc. So it's really not the preferred way if you want to maintain something over time. But of course, the strategies of clean code still apply for a strategy like MDriven, where you do models. Meaningful names, very important. Small and focused functions, of course. Readable, not clever. This is actually something that comes very naturally when you listen to the people with the actual business problem and you do what they say, and you see what that yields in terms of model. Consistency. Well, it's hard to not be consistent if you have this strategy that you're going to focus on the business problem and do classes and associations from what the business people say. Refactor repeated code. I'm going to leave that. Comment and document. Comment and document, that's pretty much useless. You won't do it. You won't have the time. And of course you can have the ambition, but it won't happen. And if it happens, you will find that it goes stale because you have changed the code after you wrote the documentation, and the documentation no longer reflects what the code does. And then the documentation just tricks someone to think that they understand what the code does, but they don't know. So it's much better to raise the level of abstractions up to models. And once you're on a model, you don't need to do extra documentation because the model is the perfect thing to work as documentation.
Code more readable and easily maintainable. One big mistake we often make when writing new software is that we take the opportunity of new projects to follow the most recent dev trends and test new technology stacks.
This is an important reflection that it does. All engineers, especially consultants or hired engineers, software engineers, they want to work with something cool, something that builds their own CV so that they are better equipped to get the next assignment after this one. That's not necessarily what's best to actually get the things off the ground and build robust information systems that actually work over time. Because if we always work with tools that are unfamiliar to us, that are new every 3 years, and we think that this is the last tool that we're going to embrace because this is the newest, coolest, and it will never be replaced, we are sorely mistaken. There will always be new things. And that's why MDriven sort of chooses to separate these two things. The gist of the system, which is the important information description of what the business problem, what kind of business problem the system solves and how it solves it. That's one thing. But the modernity, the current state of tools and technology, we know that this is old. We replace this continuously at MDriven and provide you with new engines to run depending on the latest trends. So we do the tough work of rooting out what's good and bad about new trends, and then we give you a new engine and you just change where you want to execute your models. This is a very much more efficient way to see, to look at progress when it comes to information systems.
There is a time and a place to acquire new skills. Most of the time, however, this is not during the development of software meant for production. The bottom line is that, sadly, knowing all this theory will not make you a better developer. Good software is the result of previous poor design decisions, thousands of lines of spaghetti code, technical debt, and a lot of other lessons learned from past projects. You are not failing, you just found 10,000 ways that won't work.
So as you embrace MDriven and use like MDriven Server and MDriven Turnkey, you actually get the benefit of having vetted code that has run millions and millions of hours to ensure that it does what it should on the level of abstraction where you add value, namely adding classes and associations, transforming those into use case views, and adding functionality to update this information. And you don't need to bother yourself with how that information is going to live in your SQL Server database, or how that information is transported all the way out to the end users' browsers to actually be displayed and made editable there. That's a lot of boilerplate that you don't need to write, and it's a lot of boilerplate that you don't need to test, and it's a lot of boilerplate that has been done once and tested millions of times.
And if you are happy with the code you are writing today, don't get your hopes up. It'll still suck when you'll have to debug it 6 months from now.
So I think this was a very good overview of the problematic things with code. And if I were to add my 2 bits to this, is code has way too many degrees of freedom to describe information problems in information systems. It can be used. I'm just saying that it's the most expensive way we know to get rules into an information system that is going to be subject to continuous change and maintenance. And probably one of the cheapest known ways today is using a strategy like MDriven, being declarative, working with models, and just changing the models and having the system follow. That's letting the computer doing the tough work and not you every time. So thank you for listening, and check back for news.